Hello everyone. Today I will explain on heat processing, which mainly focusing on baking, roasting, and frying. Basically, food can be cooked in two ways. The first way is by dry heat cooking method, which is use air or fat or oil to cook the food. Another method is by moist heat cooking method, which is uses of water or steam to cook the food. Baking and roasting. The purpose of baking and roasting is to preserve the food by destruction of microorganisms and reduction of water activity. However, baking is the term often applied for flour-based food, whereas roasting is the term used for applied for meats, nuts, and vegetables. Baking and roasting involve simultaneous heat and mass transfer. Heat is transferred onto the surface and air in the oven. At the same time, the moisture is transferred from the food to the air that surround it and then removed from the oven. Heat can be transferred into two ways. The first is by conduction, which is the heat is moved from one item to another through direct contact. And the second way is by convection, which is the heat is transferred through a fluid by circulation. All baked products need most or all of these basic ingredients, such as flour, leavening agents, fats and oils, sweeteners, salt, and other ingredients such as egg and flavoring agent. There are some physical and chemical changes during baking. Let's watch the following video.
In a time-lapse video, it looks like a monster coming alive. For a moment, it sits there innocuously. Then, ripples move across its surface. It bulges outwards, bursting with weird boils. It triples in volume. Its color darkens ominously, and its surface hardens into an alien topography of peaks and craters. Then the kitchen timer dings. Your cookie is ready. What happened inside that oven? Don't let the apron deceive you. Bakers are mad scientists. When you slide the pan into the oven, you're setting off a series of chemical reactions that transform one substance, dough, into another, cookies. When the dough reaches 92 degrees Fahrenheit, the butter inside melts, causing the dough to start spreading out. Butter is an emulsion, or mixture of two substances that don't want to stay together, in this case, water and fat, along with some dairy solids that help hold them together. As the butter melts, its trapped water is released, and as the cookie gets hotter, the water expands into steam. It pushes against the dough from the inside, trying to escape through the cookie walls, like Ridley Scott's chest-bursting alien. Your eggs may have been home to squirming salmonella bacteria. An estimated 142,000 Americans are infected this way each year. Though salmonella can live for weeks outside a living body, and even survive freezing, 136 degrees is too hot for them. When your dough reaches that temperature, they die off. You'll live to test your fate with the bite of raw dough you sneak from your next batch. At 144 degrees, changes begin in the proteins, which come mostly from the eggs in your dough. Eggs are composed of dozens of different kinds of proteins, each sensitive to a different temperature. In an egg fresh from the hen, these proteins look like coiled-up balls of string. When they're exposed to heat energy, the protein strings unfold and get tangled up with their neighbors. This linked structure makes the runny egg nearly solid, giving substance to squishy dough. Water boils away at 212 degrees, so like mud baking in the sun, your cookie gets dried out. and it stiffens. Cracks spread across its surface. The steam that was bubbling inside evaporates, leaving behind airy pockets that make the cookie light and flaky. Helping this along is your leavening agent, sodium bicarbonate, or baking soda. The sodium bicarbonate reacts with acids in the dough to create carbon dioxide gas, which makes airy pockets in your cookie. Now it's nearly ready for a refreshing dunk in a cool glass of milk. One of science's tastiest reactions occurs at 310 degrees. This is the temperature for Maillard reactions. Maillard reactions result when proteins and sugars break down and rearrange themselves, forming ring-like structures, which reflect light in a way that gives foods like Thanksgiving turkey and hamburgers their distinctive, rich brown color. As this reaction occurs, it produces a range of flavor and aroma compounds, which also react with each other, forming even more complex tastes and smells. Caramelization is the last reaction to take place inside your cookie. Caramelization is what happens when sugar molecules break down under high heat, forming the sweet, nutty, and slightly bitter flavor compounds that define, well, caramel. And in fact, if your recipe calls for a 350-degree oven, it'll never happen, since caramelization starts at 356 degrees. If your ideal cookie is barely browned, like a Northeasterner on a beach vacation, you could have set your oven to 310 degrees. If you like your cookies to have a nice tan, crank up the heat. Caramelization continues up to 390 degrees. And here's another trick. You don't need that kitchen timer. Your nose is a sensitive scientific instrument. When you smell the nutty, toasty aromas of the Maillard reaction and caramelization, your cookies are ready. Grab your glass of milk, put your feet up, and reflect that science can be pretty sweet.
The shelf life of fried foods is determined by the moisture content after frying. The higher the moisture content, the lower the shelf life of the foods. This is due to the water or oil migration during storage. This circle is represent food. The outside, which is the white part, is represent hot oil. Whereas this dotted line is represent the porous structure of the capillary for food. During frying, heat is transferred from the hot oil to the surface of food through convection. At the same time, the water from the surface of food vaporizes as steam, as the surface temperature increases rapidly. The surface then begins to dry out, then increases to that of the hot oil temperature, thus crust formation. However, the internal temperature increases more slowly toward 100 degrees Celsius. Heat is transferred from surface to the internal of food through conduction. During frying, both water and water vapor are removed from the large capillary first, then replaced by hot oil. At the same time, nutrient loss during water evaporation. The nutrient degradation in the surface is higher than in the center of food. Through this frying process, the microorganisms and enzymes also can be disrupted. During frying, the physical and chemical properties of the food and oil will be changed due to the presence of oxygen, water, and heat. For the food, the crust will be formed. The taste and the color of the food will be changed. The development of pores happen. However, the nutritional value of the food will be degraded. During frying process, the high temperatures of oil, the moisture from the food, and the oxygen from the surrounding will cause oxidation and produce two types of byproducts. They are volatile decomposition products, VDP, which cause unpleasant flavors or smoke, and non-volatile decomposition products, NVDP, which cause the darkening of the oil. There are two main methods of frying, which are shallow frying and deep fat frying. For shallow frying, this method is suitable for foods that have large surface area to volume ratio. The heat is transferred from oil to the food through conduction. However, this method produces irregular browning of the fried foods. Whereas for deep fat frying, the food is cooked by total immersion in hot oil. This method is suitable for food with irregularly shape. Heat transfer is a combination of convection within the hot oil and conduction to the interior of the food. Hence, all surface of the food receive a similar heat treatment and produce more uniform color and appearance. The time taken for food to be completely cooked depends on the type of food, which refer to their composition and structure, the temperature of the oil, the method of frying, which are shallow or deep fat frying, the thickness of the food, and the required change in eating quality. Vacuum frying is used to solve the problem of irregular or not uniform color of food produced by shallow frying and high oil absorption and chemical and physical changes of the oil. Vacuum frying is a frying process that is carried out at low pressure below atmospheric level, and low temperature. Hence, the nutrient loss and oxidation are reduced. Here are advantages of vacuum frying. The color of the food is well preserved, hence this method is suitable for production of high sugar content products. Low moisture content and low water activity of the food can be achieved, hence longer shelf life of food is produced. Moreover, the shape and the heat-sensitive nutrient can be retained. This method can prevent the formation of carcinogenic compounds. It also produces the less fat content of the end product, and it has less adverse effects on oil quality. We can see that the color of the end product is well preserved by using vacuum frying. The end of the presentation. Thank you very much for your kind listening.